Alright guys, since some of you have been out for TFIM on Thursday and Friday, I figured I would film a very short video for you just to help you out with the material so that you don't get behind. In your notes, I'm just doing example 4 and example 5. We did them in class, so just real quick, I'm going to go through them and that should help you on your homework and keep you guys on track. So anyway, just to kind of show you our roadmap that we've been using, we had our representative particles, we had our mass, we had our moles, and we had volume kind of down here. And these were all connected as such. Alright, so we're kind of going to use that. I'm going to use kind of like a stop light. We'd have green for go, yellow for red, I'm sorry, yellow for caution, and red for stop. So just to kind of help us with that, I'm going to use those colors over there. So as we've been doing, you're just going to put what you're given. So I have 0.13 grams over 1. So that tells us we are starting at grams. And obviously grams is going to be mass. So for our starting point, I'm going to highlight mass in green. So that's what we're starting at. And let's see where the problem is asking us to go to. It's asking for how many molecules are in 0.13 grams of K2SO4. So molecules are going to be representative particles. Representative particles are going to be molecules, ions, atoms, formula units. So that's where we want to get to. That's going to be our stopping area. All right. But if you notice, if we're starting at mass, we don't have a direct connection point from mass to representative particles. So what we have to do is we have to first go down to moles and then go to representative particles secondly. So what I'm going to do is I'm going to start my first conversion factor. Since I have grams on top, I have to put grams on the bottom in our first conversion factor. So I'm at mass, I need to get to moles. So moles is going to go on top. Now the problem with this question is that it doesn't give us a very nice just one element where we can quickly find the molar mass. Instead it gives us K2SO4. And what we have to do for this is calculate our molar mass of the potassium sulfate. So K, we have 2. We're going to multiply that by our mass of potassium, which is 39.1. And when we multiply that, we get 78.2. Second, we're going to do sulfur, which is 1 times sulfur is 32.07. Multiply those together, we get 32.07. And then lastly, we're going to do our oxygen. I have 4 oxygens. Our molar mass of oxygen is 16, and we get 64. We're going to add all those together, and I got 124.27 grams per mole. So what we can do now, guys, is take this number and put it into our conversion factor. So we have 174.27 grams per 1 mole. All right, that's the hardest part to this problem. After that, it kind of gets a lot easier. So far, I have canceled out my units of grams. They are gone. And if you notice, I'm left with moles on top. So right now, I'm at moles. So that's going to be our yellow light. We're almost to our answer. We're almost to our stopping point, but not quite. So I already went to here. I just got to finish and go up to representative particles. Our last step, I have moles on top, so I need moles on the bottom of my next conversion factor in order to eliminate those units. And in 1 mole, I have 6.02 times 10 to the 23rd molecules. But I don't want to use molecules because it's going to be moles. It kind of sounds like molecules, so I'm just going to call them formula units or FUs. Lastly, we're going to multiply everything on the top. If you're using your graphing calculator, guys, how you enter 6.02 times 10 to the 23rd, I think it's the easiest way to do it. After you type in 6.02, hit your second button, and then right above your number 7, you have this little comma with double E's above it. If you hit that, that E means times 10, and then you can just type in the 23. Okay, so 0.13 times 6.02 times 10 to the 23rd and then you're going to divide that number by what's on the bottom, which is 174.27, and we get 4.49 times 10 to the 20th formula units. Okay, so that's how you do the first problem there. This is going from our mass to our moles, and then finally our representative particles. So it's a two-step problem. Okay. Next one, example 5. Let me write down our little roadmap again. We have our mass, we have our representative particles, we have our moles, and we have our volume at the bottom. Connect everything. So, starting off in this problem, it tells us that we are given 3.89 times 10 to the 23rd molecules of magnesium chloride. So, as always, take what you're given. I'm just going to write an E for times 10 to the 25th. Instead of molecules, I'm going to write FUs. Put it over 1. So, I'm starting at RP on this one. And RP is going to be in green because this is our starting area. Now, let's look where it is telling us to go to. It's asking for how many grams. So for our stopping point, which I'll make in red, that's going to be our grams, which is our mass. Right? So we're starting at representative particles. We need to first go to moles, and then we will get to our mass. So for my first conversion factor, I'm going to put FUs on the bottom, and I'm going to moles, so that's going to be on top. So in 1 mole, I always have 6.02 Avogadro's number times 10 to the 23rd formula units, and that so nicely cancels out my FUs or molecules of magnesium chloride. Now, our second part, which is a little bit harder, I have moles on top, put moles on the bottom here, and I don't know how many grams right now are in 1 mole of magnesium chloride, so let's go down to the bottom. mg's, I have 1. Our molar mass of magnesium is 24.31. 1 times 24.31 is obviously 24.31. Chlorine, I have 2 times the by our molar mass of chlorine, which is 35.45, and I get 70.9. Add these together, and I get 95.21 grams per mole. So now we're going to add that into our equation. So we're going to put it on the top, our 95.21 grams in 1 mole. Lastly, we're going to multiply everything across the top. So I have 3.89. Hit that second comma, and then 25. We're going to multiply that by 95.21. And then we're going to divide that answer that we get by Avogadro's number, and I get 6,152.27 grams. So this was just going both ways, guys. Hopefully it helped you out a little bit. Okay, the big thing is make sure you're following this chart. We can't go right from representative particles to mass. We have to go through moles first, okay? So that's why these problems became two-step problems, all right? So in the remind, I'll send you guys with the link to this. I'll tell you your homework assignment if you were in TFIM for the last 2 days. Have a good weekend, guys.